In this course, we're going to talk about Python and how Python manages large data sets, and then we're going to discuss PyScript and the PyScript dashboard and how it helps to integrate Python and JavaScript in the browser and allows us to make use of large libraries. So, most welcome, and I hope you enjoy this course. Before we start with PyScript, let's discuss the importance of Python in manipulating large data sets. Python has become a cornerstone in the world of data science due to its powerful libraries, scalability, and flexibility. Here's why it excels in handling large data sets. Python boasts libraries like pandas, numpy, and dask, which make data manipulation highly efficient. Whether it's filtering rows, aggregating values, or reshaping datasets, Python has tools for every task. For handling extremely large datasets that can't fit into our local memory, Python libraries like Dask or PySpark allow distributed computing, which means they split data into manageable chunks that can be processed concurrently. Dask, for example, allows us to load data in chunks, meaning breaking large data sets into smaller, more manageable parts or chunks and processing them piece by piece. Approach is very useful when working with files that are too large to fit into our RAM all at once. Loading data in chunks means breaking a large data set into smaller, more manageable parts, chunks, and processing them piece by piece. This approach is especially useful when working with files that are too large to fit in a computer's memory, the RAM, all at once. Using pandas, for example, with Python to clean and analyze a dataset with millions of records, such as financial transactions, calculating a GDP, for example, of a whole nation. You could filter out fraudulent transactions using custom logic, is one example. I'm going to show you that being typed in the next slide. But Dask, has anyone heard of Dask? Dask is used for handling extremely large data sets. So if we said pandas handle data sets in the millions, Dask handles data sets that are in the billions. Actually, it's used to handle data sets that are too large to fit in a typical computer's memory. Python libraries like Dask or PySpark allow distributed computing. They split data into manageable chunks that can be processed concurrently. Example, let's say we want to analyze social media interactions. Here you got to think like billions of tweets to understand trending topics, for example, using Dask. With libraries like scikit-learn, it's hard to pronounce that one, TensorFlow, and PyTorch, Python has become the go-to language for machine learning. Thanks to its ease of use, extensive ecosystem, and powerful libraries that streamline data analysis and AI development. So whether you're building a predictive model or you're training a neural network or analyzing massive data sets, Python has the tools to help you with that. So it really is a rich ecosystem uh, with libraries like Scikit, like TensorFlow, like Keras. They really simplify machine learning tasks. They're great for data processing, they're easy to learn, and they're scalable. So we're not going to go through the details of every library right now. I will show you a code and its explanation about machine learning. So this is still a course, just a short course about PyScript. So we're not going to go into the details of machine learning. But since I gave you this code, I cannot just keep you hanging. So I'm going to explain this code very fast. What this does is first it imports the libraries as usual, which is really great in Python, by the way. So we import the random forest classifier, then it prepares the data, then it splits the data, then it trains the model. How does it train the model? Um it creates an instance of the random forest classification algorithm, which is basically a class that we imported from the library. And how we use this class is that we create an instance of it, which is the backbone of object-oriented programming. So this is the learning algorithm, and there are functions. There's the model.fit, and it takes two attributes, the x and y trains. So the model learn patterns and relationships between the features in the x train and the y train. Sorry, it churns the outcomes in the y train. So this is the training phase. And then based on that, it makes predictions. So predictions is a variable. We call it a variable predictions equals to using the function model.predict, giving it the parameter x test. So the trained model uses the features in the unseen x test data to predict whether each customer in the test will churn or not. So in essence, it loads the data, prepares it for learning, trains a machine learning model to recognize patterns associated with churn. I'm going to explain what churn is. And then uses that trained model to predict churn on new unseen customer data. So this is how a machine learns. So churn refers to data that indicates when and why customers stop using a company's products or services. So it's the information related to customer attrition or turnover. It's like the digital footprint of customers who have churn, meaning they cancel the ones we lose, the ones that cancel their subscription for whatever reason, close their account, switch to a competitor, or otherwise. So this is what churn means in this context. Okay, back to Python and why it's important in data manipulation. One of the most important things it does is the visualization. So how would you visualize data without Python? With Python libraries like matplotlib, seaborn, or plotly, we can create powerful visualizations to make large data sets more digestible. So with all that said, let's move to PyScript. PyScript is a tool for web developers and Python users. Because many of Python users usually are back-end programmers, so not all of them do web development. So this is more targeted towards those who want to mix web development with Python, offering an ability to run Python code directly on the browser, which is great, using WebAssembly. Um, so it eliminates the need for backend servers, for example, to execute Python code. It empowers users to build web applications with Python for both the logic and the interface. So it reduces development overhead. It provides seamless integration, and I've tried that. So Python becomes a partner to HTML, you can say, enabling developers to use Python's ecosystem of libraries for tasks like data processing, machine learning, and visualization directly within the browser. So, yeah, this is really interactive Python applications can run directly on a user's device without requiring installation or special environments. So this makes it really accessible and gives us access to all sorts of web-based tools. Usually this was the domain of JavaScript, but with PyScript, basically, for me personally, it's like turning Python or merging Python and JavaScript. So combining tools like PyScript and the Python libraries opens new possibilities for sharing data insights interactively in the browser. So imagine an app that lets users upload data, clean it using pandas, for example, create visualization using matplotlib, all with no backend required. So it integrates, you can say, to summarize, it integrates web development with Python. Using WebAssembly, it leverages WebAssembly-based Python runtimes to bring Python code into the browser without requiring any server-side execution. Um, it We can also use specific HTML APIs with it, making it really easy to write huge, large interactive web applications using Python for computation and logic. Um, for example, you can manipulate HTML elements or handle events directly using Python instead of JavaScript. So think of it as Python's answer to JavaScript for the web. So the best way to explain the value of PyScript and how it's interconnected with JavaScript on your browser, let's check out a practical use case. So imagine building a web-based dashboard where JavaScript populates global variables based on user interactions. For example, for inputs from forums or navigation events. So using PyScript, you can access these variables effortlessly in Python for computation or manipulation. This eliminates the need for complex JavaScript Python integration, making development faster and more intuitive. So check out the next slide to see an example of this, of how JavaScript captures user input, stores it in a variable we're going to call window.user_data, and then you can process this data directly using Python. So PyScript acts as a bridge, you can say, enabling Python to interact dynamically with web-based elements, blending the strengths of Python and JavaScript. The explanation here is highlighting a powerful two-way bridge that PyScript creates between Python environment running in the browser and a JavaScript environment of that browser. You know, most browsers are made with JavaScript. So it's saying that the PyScript.window object, you see here, you can line 3 in our code, window.user. So, uh, excuse me, this object acts as a shared space where Python and JavaScript can interact by exchanging objects. So let's break down this core idea. Basically, it is that the PyScript.window object can be used as a shared global scope. Think of PyScript.window as Python's way of directly accessing and manipulating the global scope of a JavaScript environment in the web browser. The global scope in JavaScript is where variables and functions declared without a specific scope, like inside a function. So this is where they reside. And they're typically represented by the window object in browsers. So this is a very important object in JavaScript and JavaScript environment. Don't worry if you don't understand all the terms. We can go through them, like global scope, and it's the same as in Python when you indent, or if a function is outside the scope of a certain class, inheritance, stuff like that. So we'll go through these later, but let's stick to the core issue of PyScript. So think of it in this analogy. Imagine two rooms. We're going to call one Python land, the other JavaScript junction. PyScript.window is like a special doorway that allows you to reach into JavaScript junction from Python land and place things there. So it's a bridge, like we said before, and vice versa. So it's a two-way bridge. Let's go through these three lines, code line by line, word by word. So line 1, from PyScript import window. This part indicates that we are importing something from the PyScript library, which is a core of the PyScript framework, and it allows us to write and execute Python code directly from within HTML. Import window. This specifically imports an object named window from the PyScript library. A window object. In the context of web browsers and JavaScript, the window object represents the global scope. It's the top level object that contains other object functions and variables available in the browser environment. PyScript provides a Python interface to this JavaScript window object, which means that through PyScript.window, your Python code can interact with the browser's global JavaScript environment, and you can access JavaScript variables, functions, or even create new ones. Let's move to line number 2, processed underscore data. This is a variable name equals window.user, the object that we just spoke about, underscore data.strip. This is a function, dot lower, another function. These are built-in functions in Python. So this line performs a series of operations to process some data that is assumed to be accessible as a property of the JavaScript window object. The part that says window.user underscore data, here we're accessing an attribute named user underscore data of the window object that we imported in the previous line. So we are making an assumption here. The code is assuming that somewhere in the JavaScript code of the HTML page uh, has been defined and assigned a string value. So PyScript makes this JavaScript variable accessible to the Python code through window.user underscore data. So you need an example to better understand this, because in every PyScript, it's not just the Python code. You have an HTML page and a .toml file or a .json file. So imagine the HTML has a JavaScript block that's just window.user data, our same variable, and it's equal as any string, some user input. So a user has some input on that website, and it's we have a variable name for it. So in this case, this variable name in the Python code would refer to the string that's inside it, so that's some user input or whatever it is. So this is a standard method, a standard Python string method. It's being called here on the value that was retrieved from window.user underscore data. So the functionality, we're using the strip method also. This is a Python built-in method that removes the trailing white space from the beginning and the end of strings. Yeah, and then we're using also the lower method, which converts everything to lower cases. So it's all pretty simple. And then line 3, we're gonna print our processed data variable, which was defined and initialized in line 2. Okay, so we're printing, but we are also uh, using the console. So we're going to use also, it's like we're printing both on Python, using Python and JavaScript. So process data, this is process underscore data. This is the variable that we assigned the process string in the previous line. So it will print the value of this variable to the browser's console. This allows us to see the result, removing white space and converting it to lowercase. We can do whatever we want with that after when it's right there in the variable. So as you can see, PyScript acted like a bridge, enabling Python to interact dynamically with web-based elements, blending the strengths of both Python and JS. In PyScript, every application is made of always a Python file, a Python script, an HTML, and a JSON or TOML file. This is the HTML of this sample, and check out the beautiful output. So you can check out the details by yourself. You can review these slides and try the code out at the using the dashboard, PyScript's own dashboard. So you don't have to go through the hassle of setting up the environment on your local, and trust me, it's much easier. And this is the output here. So this is visualization of data. This is an example of how to use the altair in PyScript. In this application, we're using the movies dataset from the Vega underscore datasets package to create two graphs. The first graph on top creates a heat map of the IMDb ratings and the Rotten Tomatoes ratings of the movies. The second graph creates a bar chart of the movie's genre. So you see how cool is that with PyScript? As you can see here, this is another example. This application is based on the famous XKCD comic in Python. It creates an anti-gravity class to load a SVG file and then use PyScript to display and animate it. It also shows you how you can import a file and use it in your PyScript application. Check out the pyscript.toml to see how it's done here. Bear with me a bit, just to show you how Python defies gravity on your browser. Let's try one last PyScript application. This is the Python script for the API proxy tutorial. It is designed to teach us basically how to interact with APIs through a proxy. In the context of PyScript code, it demonstrates how to make API requests using fetch, uh, process responses, and potentially modify or filter data before presenting it to the user. So how does it work? What does an API proxy do? The API proxy acts as an intermediary between our application and an API. So there's security and control. It can filter requests, enforce authentication, and manage access. It does data processing. It can modify API responses before sending them to the client. It can limit rates, so prevents excessive API requests from overwhelming a service. And it shows us how to send requests to an API via a proxy, demonstrating how to handle JSON responses in PyScript. Here it's through the TOML file. It's the same thing basically, same results basically. And it can include interactive examples where users can experiment with API calls. This script uses PyScript's fetch function to make an asynchronous HTTP GET request to an API that checks the status of proxies. Once the response is received, it converts it to a JSON format and prints it. Here, when we run it, it's going to give us an output which is OK, the string OK, which suggests that the API is returning a simple confirmation message. So while it might appear very simple, very basic, it's doing great things under the hood, which is connecting to this API and returning a simple confirmation message. Now we can experiment with this by modifying the request. We can change the endpoint to another public API. We can print type response or response.keys. Use the response.keys function to explore the structure. Might be used by PyScript to structure the application setting or by external tools to index and retrieve information about the project. Since your PyScript HTML file references PyScript.toml, this means that this will be definitely influencing the behavior of the script by defining characteristics of the project based on what's inside the PyScript.toml. Yeah, so we said that this is part of the PyScript application. This is the HTML part of the PyScript application. This HTML is structured to run a PyScript application in the browser. So if we break it down, we have its structure and purpose summarized in the first line, the doc type HTML. This declares that this is an HTML5 document. The head section contains metadata, styles, and scripts. What's very important here is in the title tag, the API proxy tutorial, which defines the page's title, but it tells us that this is about connecting to an API. In the body of the HTML code, we see we can run the Python from here using the main.py. Settings are from the PyScript.toml, and it allows the script to run without blocking page rendering in asynchronous response, and it displays output in the terminal. Now in the toml file, this is where we configure everything. In our toml, we have the name, which specifies the name of the PyScript project, API proxy tutorial, a description of it, which should be a brief summary of the project, the tags, features, and tutorial. They categorize the project with relevant keywords, helping to organize and potentially filter. This metadata might be used by PyScript to structure an application settings or by external tools to index and retrieve information about the project. Since our project PyScript HTML file references PyScript.toml, this influences the behavior of the script by defining the characteristics of the project. And here you go, folks. This is the output. The image on top is the zoom in, so you can see it's the same image below and above. This is the output of the execution of this PyScript application. As you can see, it retrieved the API and sent us a response.